Hi, my name is Tyler Dick, and this is my first video homework problem for Physics 222 with Professor Rembold. The problem is that I need to demonstrate that I can use an electric field that varies with position to calculate the movement and position of a charged object through several iterations. Alright, so let's get started. As you can see, I have the initial components of the electric field. The electric field is equal to 4y 3xz, which varies based on the position of the charged object. The initial position of the object is 152 meters. The charge of the object is negative 30 millicoulombs, which is negative 0.03 coulombs. The mass is 15 grams, or 0.015 kilograms, and the initial velocity is 0, and that's just to make the initial momentum calculation a lot easier. So to do an iteration problem, we first have to calculate the force. So to do that, the force, in this case, we can calculate with the charge times the electric field. And to do that, we have to figure out the electric field of the initial point, which is going to be, we're just going to plug in those numbers from the initial position, 152 meters, into the electric field, which will produce 23.2 newtons per coulomb. And calculate the force, we'll just multiply the initial charge, which is negative 0.03 coulombs, times the electric force, the electric field that we got. And that will give us negative 0.6, negative 0.09, and 0.06 newtons. Now that we've calculated the force, we can update the momentum using the momentum update equation, which is the final momentum is equal to the initial momentum plus the net force times the change in time. The time step is going to be 0.5 seconds. So our initial momentum is going to be 0 just because our velocity is 0, and momentum is equal to mass times velocity, which means our final momentum is going to be equal to 0 plus the force that we calculated from the electric field and the charge times the time step of 0.5 seconds, which is going to give us a final momentum of negative 0.3, negative 0.045, and 0.03 kilogram meters per second. Now that we've gotten the momentum, we can update the position with the position update, which is final position equals initial position plus the average velocity times the change in time. We already have the initial position, 152 meters, and to get the average velocity, we're gonna divide the momentum that we just got by the mass, and then multiply that by the time step of 0.5 seconds. So once we do that, once that's all divided and calculated out, our final position is going to be negative 9, 3.53 meters. Now that we've gotten the new position of the mass, we can do another iteration by calculating the electric field of that new position using the position that we just got. And doing that, we would get 14, negative 27, and 3 newtons per coulomb. And from there, we could do the same thing that we did earlier with the force, just multiply negative 0.03 coulombs times the electric field, and we're going to get negative 0.42, 0.81, and negative 0.09 newtons. Alright, from here the rest is basically just stuff we've already done. We're going to update the momentum using the momentum that we got from the first iteration as our initial momentum, and then multiply that time, or add that to the new net force times 0.5 seconds, giving us our new final momentum. Then using that new final momentum to calculate our new final position, using our previous final position, which is now our initial position, and then calculating all that out, we're going to get our final position is negative 26, 7.5, 3.5 meters. Thank you.